value. What is a p-value and how to get it? So how to get it, I just said it before the tape was turned on. I'll repeat it. How to get a p-value and how to interpret a p-value. Those are the two things I'd like to talk about in the remaining 4 minutes. Okay, and so let's bear with me. So again, I only have 3 or 4 minutes, and 2 or 3 minutes really. And I've been pretty good about not keeping you late, but I might have to keep you 1 or 2 minutes late today. And in reparations for that, I will cancel a class at some point between now and the end of the term, maybe more than one, but for sure one, to make up for the fact that I may, on occasion, keep you a couple of minutes late. So I think you'll owe me more time than I owe you. Okay, now. So the way to how to get a p-value. So there are of course some ways to do it on a calculator. For those who have calculators, you can get it by using different computer programs on the internet. But the way we're doing it for this class officially, you can do it any way you like, of course. But officially is to go to the Excel, in particular the PHStat add-on, which I think is probably available free, but it comes with the CD in the back of the textbook that most of you bought. And at some point, you're going to type in the relevant numbers, and you're going to get a p-value. So that's how you get the p-value. So when I ask you to do this example online, you have to make a digression, go to the Excel, go to the PHStat, get the p-value. So that should, if you do it correctly, you shouldn't be making a mistake there. The only question is, how do you interpret a p-value? So in order to interpret the p-value, I can give you the rule. The rule is very simple. First, I'll give you the rule, then I'll try to explain the rule. So the truth is, you don't have to understand why this works, but I would like to explain that to you. But the rule itself is the following. If the p-value, let's call that p. If the p, we'll call that p. If the p that you get out of the printout, or that you somehow obtain, or the computer tells it to you, is lower than the alpha, okay, that means that you're supposed to reject the A0. And conversely, or inversely, if the p is bigger than or equal to the alpha, you're supposed to interpret that as do not reject A0. Okay? That's it. So that's, again, getting it, the numbers will be hard to do by hand, but you don't have to do it by hand. You do it on a computer. And once you get it, and the question is, do you accept or reject? If the p-value is smaller than alpha, you reject, and if it's not, you do not reject. That's the simple rule. Now the question is, what is a p-value and why does it work that way? Okay, we have 30. Okay, let me just say it quickly. The p-value is the probability of getting the result that you got. And we get all these experiments end up with data. So the question is, how likely is it that if the average is truly 8.17, would you get a value as low as 8.151 or even more extreme than that? That's really the question. So what does that mean visually? Well, let's take this picture. Here's the picture. And remember, probability is area under the curve. So where is minus 2.44? So minus 2.44, let's say, is right here. So what the computer does for you when it calculates a p-value, it calculates the probability of getting a value as extreme as minus 2.44, which essentially is the area under the curve. Now, the fact that it's so far out means what? Will it be a small area or a big area? It's going to be a little piece over there, a really small area. Now, if it turns out, if this number came out to exactly minus 1.6766, if it came out exactly on the borderline, how much area would there be to the left of that, by definition? Good. Still no name, but I'll give you your paper. 5%, because this boundary is defined to be, so 5% is here, and 5% is here, because we started out with an alpha of 10%. We chopped it in half. So if we ended up with an area lower than 5%, what does that mean? It means that you have to be in what region? To the left of the boundary, you have to be in the extreme region, you have to be in the reject region. So that's why the rule works. If the p is less than the alpha, that means the only way that's possible if you ended up in the reject region. So if you have a way of calculating the area of being to the left of 2.44, and that turns out to be a really small percentage, that means you have to be in the reject region. So again, that's why the rule works. The only complication is because when we're calculating things at random, we're calculating the probability of certain random events, just like you can get a value of 2.44 just by bad luck. there's an equal chance of getting a value higher than 2.44. And so for technical, maybe I'll explain this in more at length more next time. But when you're dealing with a non-directional test, which we are here, remember equal versus not equal, there's no direction. There's no greater than or less than. If you're a non-directional test, you're supposed to take that percentage and double it, just like we take the alpha and chop it in half. You sort of reverse that process. So when I say the p-value is the area to the left of that number, which is that little piece over here, the computer then takes that number and doubles it automatically, so you don't have to bother chopping it in half. It just sort of does it for you. So after all is said and done, and if that wasn't clear, and I don't expect it to be totally clear, you don't have to double anything. You just simply take the p-value, compare it to the alpha, and make that decision. So again, if it's not clear, you certainly can ask me about it either after class or next time. But the main thing is to just get a p-value and interpret the p-value. The reason behind it we can discuss later.